to welcome you again to our webinar today. First of all, just a very happy new year. We haven't had one of these webinars, so this is our first one of the year. For those of you that don't know who's joining you today, my name is Peter Lum. I'm the Director of Training and Education at Enphase. And for this first session of the new year, we want to start up again with these webinars to help you, our installers, keep updated on the latest information from Enphase on best hints, tips, practices on commissioning Enphase energy storage systems. So in today's webinar, we want to provide recommendations on how you can make your system installations and commissioning go as efficiently as possible. So we do this on a monthly basis, and so we want to encourage you to join us each month as we do this, because we try to provide the latest updates on this. So these are going to be some highlights today on focal points for you as installers. We actually derive a lot of this from what we get from our customer support teams, our field application engineering teams, in terms of things that's happening in the field. So I want to pass this on to all of you in terms of what are some of the best things that you can think about as you start installing systems and commissioning those systems. Some of the things that you should do before you go out on site to improve your efficiency here. The first one is certification. As many of you know, we have a certification process with energy storage as well as IQ8. If you're installing IQ8 TV or backup systems, you have to be certified to do this. And you do this, of course, through Enphase University. So the last thing you want to do is not be certified, get on site, install a system, and not have the right credentials, because we actually will block you from being able to commission the system. So best thing to do is for all of your installers that are commissioning systems, you really need to be certified, each one of them that are on site. What we don't want you to do is actually share your login, so that installers that haven't actually taken the training trying to commission the systems. And the reason for that is oftentimes the folks that haven't come to training, they're actually missing some things. So please get certified on this and do this before you get on site. I think that'll be really helpful for you. The next thing is that you want to get the latest Enphase installer app, formerly known as the Installer Toolkit, ITK, you're probably familiar with that. But the latest version is 3.27.1. That's this month is the latest version that you're going to find on your phone. The way to get that, of course, is through the Apple App Store. If you've got an Apple device, then you want to go to Apple App Store, download the latest version of this. The Apple App Store still calls it the Installer Toolkit. So you want to search for Enphase. You'll see the Installer Toolkit, latest version 3.27.1. If you are an Android user, go to the Google Play Store and you'll be able to pick up the same version, 3.27.1. Now, all of your installers that are going to be commissioning systems to actually do this before they go on site, because you don't want to have an installer that's trying to download the app at the very last minute. So have them do that ahead of time. Also have your installer log in with their company ID. So I have an example here where I have Peter Lum at Joe's Solar Company. I don't want to use my own Gmail account or a non-company account, because then when I go to my installer app to bring up the system that I'm working on, I won't actually see those systems. I'll only see the systems that are associated with my login. So they should be logged in with their company ID. If they don't have a company ID, then they need to be added in your company as a user for Enlighten, or the Enphase installer portal. Then it'll be yourcompany.com. Okay, the next thing that we want to make sure that you're doing beforehand is that you're getting the very latest versions of software for your phone. Now, what happens is your installer app becomes a library of software for your entire system. So if you're installing an energy storage system, IQ8 system, that system has to have the right software. What we do is we actually download all of that software into your phone. And then what happens is when you get on site and your installers are then commissioning the system, the phone actually checks the revision of software on the system, all the different components, the batteries, IQ gateway, system controller, all of the components. It checks the software, and if that software is out of date, then it pushes an update to update those systems. So you want to make sure that your device has the very latest software, and the way you do this is you go to your installer app, make sure that if it says download, that you download the very latest version of software to your phone. The very latest version that we have today for gateway software is 7.03.120. When you go to your phone and you go to settings, you should be seeing 7.3.120 on the screen. If it doesn't, then you want to go ahead and make sure you hit download. It will download the very latest versions. Don't commission the systems with older versions of software. You're not going to get the latest bug fixes and things like that. A really good best practice is from a pre-commissioning perspective. Okay, let's talk about some key best practices for installation. These are, again, taken from things that we're seeing in the field over the last 30 days in terms of the things that seem to be hanging up installers. So we want to make sure we're mentioning the best practices here. Okay, the first one has to do with CT installations. I think most of you know that CTs are like a critical part of installing any Enphase backup type system. So if you're doing any system that's putting IQ batteries in or IQ8 PV for backing up a system if the grid goes out, you have to have that system fully configured with CTs, and they have to be 100% correct. And the reason we're mentioning that is that there is a high degree of errors incurred when installing systems, and a lot of those are around installing the current transformers, all right, and metering. So why do these errors occur? Lots of different reasons. Part of it is that people forget how this goes in. So I would highly encourage every installer that's not doing this on a consistent basis to be reminded of how to install CTs correctly and get the metering going. You can do this in a couple of different ways. We actually have a quick course called CT Essentials. I think it's like a 5 to 8 minute online course just to remind you of basic principles. So I would highly encourage installers to just kind of take this every so often to remind you of best practices. Second thing is to be reminded of where to put CTs. There's a specific place to put CTs and a specific place where you shouldn't put CTs. CTs for consumption should always be on the line end and not at the load. So you don't want to put your consumption CTs off of your load breaker. It always should be on the mains on the supply side. If you put them on the load side, you're going to actually cause the readings to be inaccurate in terms of operating the system. So they must be on the supply side. This is just one of those errors that occurs when installers are thinking, okay, I just want to measure consumption from my loads. To do that, you tend to want to put them on the load side, and that would be actually incorrect. It needs to go on the supply side to catch all of the energy that's coming into the home. CT wiring to the gateway, a lot of miswired gateways. That needs to be checked. And this is all covered in CT Essentials as well. And then phasing is the last one. So I'm going to spend just a little bit of time talking about phasing because this is just one of those things where installers miss this. Phasing is the perspective of when measuring power for the system to get the system to behave properly. Measuring power for the system, we're measuring power for two phases. Like all of you know, we have split phase systems, so we have power that's drawn from line 1 and from line 2, and then we add them together to get the total power for the system. Now, what happens is that in order to measure power for line 1, power for line 2, we have to measure voltage and current for each phase. That's why we actually have a voltage measurement for line 1 and a voltage measurement from line 2. And that's actually off of the main power lugs that feed the IQ gateway. That's how we measure voltage for each phase, voltage for line 1, my black line, and voltage for line 2, my red line. That's my voltage measurement. My current measurement is through the CTs. So I put 2 CTs in, line 1 CT, line 2 CT, and they get wired into my Envoy, into the line 1 terminal block positions and line 2 in my line 2 terminal block positions. The IQ gateway, which is actually my meter, the IQ gateway takes the voltage measurement and current measurement for line 1 and voltage measurement, current measurement for line 2, and then it does the math, calculates it, and says this is the power for each phase. Now, what happens is that if you miswire the CTs, like you cross these wires or you mix up line 1 and line 2, you're going to get inaccurate readings. One of the ways impacting installers where they're not catching this is phase errors. And that's when you're measuring voltage from one phase, so maybe voltage from line 1, and then you're getting current from line 2. There are times when homes are actually, there's wires that are crossed. So for example, if you're measuring, if you've got a line 1 voltage and it's actually coming through your load center and it actually gets crossed, right? You probably see my arrow here. Then what happens is that this line, which I'm getting a voltage measurement from, which is line 2, if this line coming from the utility is crossed through the load center, then actually this is actually line 1 where we think it's line 2. So you can see the problem is I'm measuring current from line 1, but as the voltage goes through my load center, I'm actually measuring voltage from line 2, right? Right, because it's crossed through here. Okay, so and this is covered in CT Essentials again, but just doing a kind of a quick summary in that you want to make sure that your CTs are wired correctly into your line 1 terminals, your line 2 CT is wired correctly into your line 2 terminal, and then your voltages are correct, that the voltage on line 1 is actually wired into the voltage terminal here, line 1, and same thing for line 2. I've got a little diagram here on the best way to check this is you use a voltmeter, and where your CT is, right, which is usually at the main load center, you take a voltmeter and you set it to volts AC. The 1 meter lead goes onto the lug where line 1 is at the main load center. And then you may need to stretch out this wire a long way, but then your second lead goes on to the line 1 feed that feeds the IQ gateway. You see this is line 1. And these should be the same phase, right? If this is line 1, this should be line 1. And if you put this to volts AC, and these are the same phase, then it's going to read 0 volts, right? Because essentially it's the same wire all the way through. Now, if something has been reversed, what you're going to see is you will see if wires are crossed somewhere through the system, then what you're going to read is you're going to read 240 volts because you're measuring actually across phases as opposed to the same phase. All right, and this is a trick that helps you quickly identify if you've got cross phases. Here's a best practice. This is a way to identify this every time. For every installation, we strongly encourage installers to do this phase check to make sure you don't have cross phases through the system. Okay, so make sure you've got 0 volts when you go from where your line 1 CT is, that wire onto your main lug, all the way to the Envoy breakers, or even right at the Envoy terminal block, right? That should be 0 volts. If you see 240 volts and you're measuring, if your meter lead is on line 1 and you go over here and that's on line 1 and reads 240 volts, you've got a crossed wire it's wired through incorrectly, or you may have one of those circuit breakers that has cross phases when power goes through the circuit breaker. All right, spent a little bit of time on this, but I think it's important because CTs, again, have errors. We see a lot of errors with CT installations, and one of the main culprits is phasing, and it's difficult to see wiring in the walls, so doing a metering check, like I just said, is really going to help identify if you've got a problem right up front. Next best practice, if you are installing load control, right? So load control, this is a load control box from Enphase. Load control sheds off loads that could collapse the microgrid. If you're installing a load control device and you start to provision the system, you want to make sure that you actually configure how these load control contacts are supposed to be configured. So that is in the installer app. There is a screen to configure your auxiliary contacts. All right, so you can have up to 4 of these contacts if you've got 2 load control boxes. And you want to make sure that you configure these before you commission the entire system, right? So what happens is sometimes people, they go through this, they don't know that they need to configure this, they just kind of bypass this. You commission the system, and then you go and you think, oh, these aren't really working the way they should. So we're gonna, the reason we didn't do this correctly is because we have to configure this. So if you configure it afterwards, what's gonna happen is that it'll actually go through perhaps a second software update to configure this properly. So the best thing to do is to configure this before you commission the system, all right? And then you're going to be taking the smoothest path forward. So I'm going to ask Jarrett, who's helping to moderate this. Thanks, Jarrett. Jarrett, you there?
I am.
All right. So how the questions coming in?
Yeah, there's only a couple of them. One of them was, how often should we check for the updates? So this was early on in the process when you're talking about how the toolkit will look for new software updates and things. And so the question was, how often do we look for those updates? And essentially the tool itself, the installer toolkit, or now the installer app, will look for those updates automatically for the Envoy software or the gateway software, as well as the battery and any storage related software that needs to be updated. It'll download those automatically for you. So once you open up the app, you can do that.
Yeah, very good.
Yep, and then the other one that just came in recently, it's asking about cutting CT wires and lengthening them out. And so the question comes in as I understand the CT balance with the length of the wire leads incorporated. I know not to cut them, but what is the solution to run the line from the MSP to make it basically elongate it from the MSP all the way to the Envoy? Is it bad to splice an additional length of wire? And for that, actually, the consumption CTs, you have that ability. We have our CT installation tech brief, and on page 11, we actually have a table that tells you to run this length of wire, extending it out, make sure you use this gauge of wire and this type of wire. So that is encouraged if we have to have a longer CT wire on the consumption side. On the production side, you never want to cut and either lengthen or shorten that wire because it is certified as an ANSI compliant device. So you never want to do that to the production CT. But consumption side, most definitely you have that ability, and the guidelines for that are in the CT installation tech brief on page 11.
Yeah, great.
Those are all the questions.
All right, so let's turn our attention to IQ8 systems. What we talked about before were general guidelines to storage systems as well as IQ8, but we want to focus a little bit on just some of the best practices for IQ8 based systems. And there's some important things I really hope that everyone will pay attention to and glean out of this. The first one is if you're installing IQ8 in just a grid-tied mode, there's no requirement, there's no certification. I mean, the requirement is that you install it properly, but there's no learning requirement. If you start installing IQ8 in any kind of backup configuration, the system starts backing up power for the home in a microgrid mode, and you're using IQ8, then you're going to need actually to get certified to install IQ8 in those configurations, because there's some unique things you really should know about what's different when you install IQ8 in a backup type configuration. Okay, there's a certification course online. It'll only probably take you maybe a couple hours to do that. Unless you are brand new to Enphase, then we want you to actually take a full PV certification course. Now, most installers that I've talked to are actually quite knowledgeable about Enphase, been doing Enphase for years and years and years. So if you are an experienced installer, we don't require you to take the PV certification course from Enphase. There's a little test out that asks you some questions just to verify that you've got the latest information about Enphase PV systems. There's some people that have installed Enphase 10 years ago when it was the M190 series, which is a very different microinverter than we have today. We want you to come back and make sure that you are up to speed on how to install IQ-based microinverters. And if you know how to do that, then we'll send you on to IQ8 training. So bottom line though, if you are not IQ8 trained, you will not be able to commission a system using IQ8 microinverters. And that's just to ensure that you're doing this properly. So I want to spend a little time talking about a specific configuration of IQ8 in backup, and that's sunlight backup. There's several different ways to install IQ8. One of those ways is in a sunlight backup configuration. And we're going to use IQ8 microinverters, which are unique because they can actually grid form. It is a multi-mode inverter. IQ8s can be installed in a configuration where if the utility fails or goes out, these IQ8s can actually start forming its own utility grid signal, given that you've got sunlight on solar panels feeding these microinverters. These microinverters will actually create a grid and continue to run loads within a home in the absence of utility. Now, there's requirements for this. The first is that, for most of you, you know this, if you've taken the sunlight backup course, you need an IQ system controller 2 and at least an IQ load controller. Remember, this is the load controller that I mentioned about earlier. So these are two mandatory components to install a sunlight backup system. And this is a backup system without batteries. There's no batteries. It's just using the sun to create power for a home if the utility fails. All right, so that's sunlight backup. So for load control for sunlight backup, you have to configure a load controller. And so the way that we know that you're doing a sunlight backup system is you're going to have 0 batteries. You would have 0 in this field, and then you would have you would need a load controller. And when you're doing load control, then you need to configure that load control. If you remember, we talked about this just a little bit earlier. If you're doing any kind of load shedding, you should configure this early so that it smooths your path to installation. If you don't, then you're going to be going back and redoing something, and it's gonna stall your time on site. All right. So if you're installing sunlight backup and load control, then you want to make sure that you configure the behavior of the load control accordingly. All right. So there's an entire load control course. I'm not going to cover that here, but there's these different modes that you configure with load control, and you want to make sure that you do this before you commission the system. All right. Now, if your installers are out in the field and they don't know what they're doing, then what will happen is they'll probably just skip this and go, I really don't know what that is. And that's not actually good. You want to configure this properly before you actually go and commission the system, because then the system is not going to behave as you expect. Please make sure that every installer understands how to configure this. A couple of remaining last critical topics. There are actually a number of errors being made, and want to make sure that we cover this in terms of best practices. The first is related to this thing we call the Enphase system shutdown switch, or the rapid shutdown device. You're probably familiar with this. If you're installing any kind of Enphase backup system using IQ8, you have to put this device in. Some installers have asked, why do I have to put this RSD, rapid shutdown switch, when I usually have just a rapid shutdown blade switch, or can't I use the circuit breaker within the combiner box to do rapid shutdown? Well, the problem is, remember, rapid shutdown is supposed to de-energize all conductors from the roof to wherever it's connected on ground level. That's the purpose of rapid shutdown. Now with IQ8s, because of its grid forming capability, if you just flip the circuit breaker off or use a blade switch, it actually disconnects power from the inverters. But remember, the inverter's job and capability is to actually produce power if the grid fails. So what happens is that if you flip a big blade switch, those inverters still produce power. And so those conductors from the rooftop down to the ground are still potentially live with electricity. And so it doesn't comply with rapid shutdown rules. The purpose of this switch, this isn't just a switch that disconnects DC power or AC power. What this switch does is it actually is a signaling device to the system controller, and the system controller does a bunch of magic to signal the inverters to stop producing power or reduce power to a safe state. So you have to use this system shutdown switch. You cannot avoid it if you're doing any kind of backup configuration. When you install this switch, there are some wiring things that you have to be aware of. Now, the system shutdown switch is like a 2-pole switch here. The way that the switch works is when you close the switch, it connects these terminals, terminal 1 and terminal 2, they're crosswise, and terminal 3, terminal 4. So if you're thinking 1 is wired through to 4, it's wrong. It actually gets crossed. You have to pay particular attention to how this is wired. Now, when you wire this, you should never wire this when the system is live. If you have rewired a customer's home and the system is up and running, installers sometimes are hesitant to have to shut down the customer's home again. And so you try to wire this switch in to get it working, and you do it when the system is live and energized. And that is absolutely something you should never do, because what happens is if you wire this live and you touch a ground line inadvertently, I mean, you can be really careful about this, but there have been so many instances of a short happening, and what'll happen is it'll damage a component within the system controller. So the first important note here is you should, and this is in red letters, wire only when the system is de-energized. So you really should shut this off. Go ahead and tell the homeowner, all right, I've got to wire this one other switch in. We're going to have to bring your home down for about 5 minutes when I wire this in. All right, and you want to make sure that you wire this when it's de-energized. Also, there is a header, all right, and that header gets pulled out. That the header actually has these terminals in it. A good safety precaution is to pull the header off, wire all these wires into the header, and then plug the header back in after you've landed all the wires. So 2 things: wire this when it's de-energized. The second is pull the header off and put the wires in. Now I've got one other item on this. There's been so many miswires on this that Enphase is now shipping this system shutdown switch with this switch pre-wired. All right, so this switch actually is inside here. And so you will get these pre-wired, it's all pre-wired, and it's numbered and it's colored. And then we have these pigtails. There's 4 of them, and these are also numbered and colored as well. So we're trying to make this as absolutely simple as possible so that you can't make a mistake in terms of wiring it in correctly. But the same principle applies, is even if you're wiring this and we're making it easy for you to wire this, you should never wire this with the system live. Now, one other note about this is that we're actually closing two separate contacts. When you flip the switch to on, what happens is it's actually connecting two circuits. If you look at this header here, you can see my arrow. We've got 1, 2, 3, and 4. When you close the switch, it actually connects 1 and 2, and it connects 3 and 4. And that's the normal operating mode of the system. You want 1 and 2 to be connected and 3 and 4 to be connected. And what that does is that enables the system to work. Now, if you were to miswire this and 1 and 2 are not connected, or 3 and 4 are not connected, the system is actually going to be in a rapid shutdown state, and so the system relays won't close properly, so it won't be in the proper configuration. So the way to test this actually is when you put this into operating mode, which is like in the vertical position. When you're going to commission the system, before you energize it, just take a meter and read, put it on ohms, and you should see with the switch in the operational position, 1 and 2 should be shorted, and 3 and 4 should be shorted. Okay? If 1 and 2 are open, or 3 and 4 are open, then your system's not going to work, and you should fix the wiring before you try energizing the system, because you're going to end up having to shut it down anyway to correct the wiring. Okay. That is just 2 important notes about the rapid shutdown device. All right, this system shutdown switch from Enphase. And again, this switch is unique. It signals the system controller to go into shutdown mode, and so you want to make sure that this is wired correctly. We actually do have a video online that talks about this as well, so check that out. Okay, the next one is the IQ Gateway power reconfiguration. Now this again relates specifically to IQ8 systems that you're configuring in backup mode. So you're going to have a system controller, and then you have IQ8s. When you are installing IQ8s in a backup configuration, you must rewire the gateway to be powered off of the common bus of the system controller. That's this bus right here. What happens is installers are very familiar with installing IQ Gateway and wiring the IQ Gateway from this bus here. All right, and this is the IQ Combiner bus. And one would think, okay, well, the IQ Combiner bus is actually connected into the system controller where I get AC. So why can't I just continue to power the gateway from this bus, because I'm getting AC here? What we're telling you is that you really need to move the power, not powered off of this combiner bus. It must be powered off of the bus that's in the system controller. All right, and there's a number of reasons for that, which one of those is that because there are relays controlling the AC to this box here, right? So for those of you that have taken the classes, you know that the power on this bus goes through a relay before it connects this to this bus. So if that relay is open, then you'll never get AC to this, and so the combiner will not fire up, right? I mean, you'll never get the gateway to be live. Now, the little caveat here is that there are circumstances where the gateway actually signals this relay to close, right? So if this gateway signals this relay to close, if the gateway is on this side, it'll never get power So if it never gets power, it can't signal the relay to close. So there's this catch-22 here, right? So the way that you have to solve this is you put the power to the gateway on this bus. So the gateway is always powered when this bus is powered. And then this gateway then can signal the relays to close, connecting the AC through, right? So that is one example of why it's important to move this gateway power to here. There's another reason for this, is that there is actually a power dynamic where if the gateway is not powered off of this bus, it actually creates an electrical dynamic in the system controller that could actually damage the system controller. All right, so two reasons why this this gateway needs to be powered off of the system controller bus. How do you do this? You simply just run wire from the IQ gateway's power terminals, and you wire them into the system controller. And where do you derive power? There's a couple different places. One is you can use the generator slot, all right, which is typically unused if you're not installing a generator. You just put a 20 amp 2-pole breaker in, and then you just wire the IQ gateway into the breaker that's usually used for the generator, and you wire it directly into the breaker. You don't wire it into the generator terminals here, you wire it directly into the breaker so that the IQ gateway is getting power directly from the bus. All right, so that's one option. There are, of course, customers that are installing the generator, and so you were saying, what do I do now because I don't have that breaker slot? So the second option then is that there is a quad breaker available for where the neutral forming transformer, the NFT breaker is. You would essentially just replace this NFT breaker, which is a 2-pole breaker, with a quad breaker, and the quad breaker will feed the neutral forming transformer and can feed the IQ gateway as well. Okay, so that's two options there. And then the other option as well is you can power the IQ gateway from the backup loads panel, because the backup loads panel is connected onto the output of the system controller, right? So if this system controller is feeding a backup loads panel that I'm just drawing here with my arrow, you could potentially feed that gateway from this backup loads panel. And again, it's got the same dynamic. It's actually being powered directly from the common bus here. Okay, all right, so the important thing to understand is that you must do this. You must, if you're installing IQ8s into a system controller 2, you must relocate the power from the gateway into the system controller. Do not do it any other way, okay? If you're installing IQ7s, different story. IQ7s, you can go ahead and just power it off here. But IQ8s, you have to then power it from the system bus. Yeah. Okay. We actually have added a check in the installer app to tell you how to test if you're actually powering the gateway from the system controller. So you'll probably see this screen. If you know what to check for, then you can kind of just go through this very quickly. But the important thing is just ensuring that you are powering from the common bus. All right, so I think I've covered that in detail. All right, there is one last thing. When you are turning PV off, all right, in a configuration where you have IQ8s into the combiner box, and then the IQ gateway is powered off of off the system bus here, or the common bus. If you want to turn PV off, you should never turn the PV off from the PV breaker. All right, that's this breaker in the system controller. All right, there is a breaker here, and that breaker is for PV, but you don't want to disconnect PV from this breaker. If you ever want to de-energize PV from the system, do not do it from this breaker. Doing this will create a voltage anomaly that could damage the system controller. So the proper way to do this is not to flip the breaker here, but actually to go to the combiner box and just flip off all of the breakers here. Now, I got a question the other time we mentioned this is, well, what happens if this trips by itself, right? So there's a short in the line, it actually trips this breaker. Is it going to actually damage the system controller? So remember, this breaker is an overcurrent protection breaker. So if you have a short across these lines that creates an overcurrent protection, overcurrent situation, and this trips, likely what's going to happen is if the microinverters detect that there's a short between these lines, the microinverters actually will stop producing. All right, so what will happen is the microinverters will stop producing, this will trip, but because the microinverters are not producing, we don't have any power that's actually going to damage the system controller. The situation here is that if you manually flip this switch off when the microinverters are producing power, then that will be the dynamic that kind of creates that problem. Okay, all right. So again, the rule is do not turn them off. Do not turn PV off here ever, right? Turn PV off at the system controller subpanel. All right. And you'll need the latest software for IQ8s. Okay. So having said that, I think we've covered pretty much most of the highlights that I think are important. And I'm going to go back to Jarrett to see if there's anything we can answer in terms of questions.
Yeah, there's actually one question that came in. It was talking about an install that they did, and they actually shortened the production CT wire. So they wanted to know if they did shorten it, do they have to go back and replace that wire? And so my comment was, well, it kind of depends, right? The CT, the production CT wire is repaired and calibrated at the factory to be ANSI compliant, and it's really used for the revenue grade metering, right? So there's at least or PPA, something to that effect.
Right.
And if you are in one of those type of installations where you are using those, then you definitely want to go back and change that wire out. But if you're not, it kind of depends. Like the accuracy will change a little bit if you do either of those to that wire. It looks like you shortened it. Accuracy will be off, but if you're not in a revenue grade metering program, you may not have to do that and save yourself a trip.
Yep. Yeah, that's the way I'd answer it as well. Is that wire is specified specifically for our certification, and as Jared mentioned, it is a revenue grade certified meter. And to certify it as a revenue grade meter, there's we have to do it with a CT with a specific length of wire into the meter. So if it gets changed, then potentially it changes the reading. How much does it change it? Honestly, I think it's such a small percentage, but for certification, we have to tell you it's got to be a certain length. So. What else you got?
Looks like there's one more question that just came in. It says, will this training be accessible after the webinar, and can I find somewhere to watch it and review it again?
Yeah, so there's two things. One is I have posted in the download section a copy of these slides, so you can pick those up. I would just click on download right now if you didn't do that before, and so you'll have a copy of these slides. I'm going to try to take the recorded section of this and post it, and so just be watching that for that online. Yeah. All right, what else you got, Jared?
That was it from my end. I'm actually uploading in the handout section as well the CT installation tech brief that we talked about earlier for lengthening the CT wires. So
Great.
I just uploaded that to the handout section as well. So if you guys are interested in that, check out that page 11 that I spoke about. That gives you the guidelines for how far that distance is, what type of wire, and what gauge to wire to use as well.
That's awesome. Thank you. All right. Did we catch all the questions?
Looks like there's one more question that just came in.
Yep.
Let me see here. It says, what is the right way to install CTs in case if we don't have access to the city service and the main breaker sits on the lugs instead of the wires? So this is definitely going to be kind of like a meter combo panel, right? Where do we put those CTs in that case?
Yep.
And so I don't know if you have a slide that can address this, where we talk about actually taking all of your L1 circuit load wires themselves and bundling them up and putting a CT around that one. And then same thing with all the L2s. That is one way to do it. It's a little bit more of a lengthy process, but that is an option to do that. So take all your load wires that are on basically your blade number 1 or blade A, bundle them up, stick your CT L1 around that, and then run that back to the Envoy, and then do the same thing for your L2s.
Yeah, that we do acknowledge that there are times when it's difficult to get the CTs around the main bus. And there's some main buses which are difficult, like they're bus bars. So in those circumstances, as Jared mentioned, the only way to properly meter all of the loads is, it's a little messy, especially in older panels, but you have to separate line 1 conductors and bundle those together, put them through the CT. And it is a split core CT, so you can open it up and then get it around all of the line 1 conductors. And then you would do the same thing with the line 2 CT around the line 2, all of the red conductors, or I won't say that, all of the line 2 conductors. Yeah.
Then there's one more question come in, and I'm not really understanding the question. So Brian, maybe you can reword it. It says, can you give more specific info on grid back system storage, where the only goal is to extend the production usage? So maybe you can clarify that a little more, unless you understood that question.
Yeah, I think I might have an idea of what he's saying, but yeah, if you can clarify, that would be great.
Yeah, let's see. Arthur just asked a follow-up question. How many CTs could be connected to the IQ gateway? I mean, the IQ gateway has 2 places for 2 CT lines. I had a thought where if we could cut CT lines with 1 meter only and splice in additional CTs, there's a place. Oh, I see what you're saying. So you can run multiple CTs on L1s and L2s in parallel. And so you can do that. The best way that I've seen people do this is where they create a pigtail. So you'll have 1 wire going into the Envoy, and then that will be pigtail to the 2 L1s in parallel, and then the 2 L2s in parallel. This is handy if you're doing a system where you've got a 400 amp panel that's feeding 2 200 amp panels, right? So you have to run a set of CTs on one panel, another set of CTs on the other. And if you want to monitor them all together, you can splice them together with the pigtail and run them into the Envoy. So that is an option to do that.
Yeah, and another example we found in our one of the previous webinars was someone said, apparently their pool was not off the main load center. And so their question was, can I have 2 sets of CTs, one on the main load panel and second on their pool feed lines? And yeah, absolutely. I mean, you can have a second set of CTs. As Jared mentioned, they get wired together in parallel. You can use, something, I mean, people have used butt splices to tie the 2 CT wires together and then a single wire into the Envoy. Yeah, the trick is the Envoy has
Wagos. Yeah.
Yeah, Wagos are better. Yeah. The trick is the Envoy terminal block doesn't take you can't get a lot of wire in there. So, yep. Okay, did we get clarification from?
Yep, it looks like he just replied in and says, don't know how to explain it better. There is no backup when the grid is down, but more the goal is to time shift 4 to 9, grid always on.
Oh, okay. So, all right. So if, and so let me see if we can clarify this. There are people that install storage, and the purpose of the storage is not necessarily for backup, right? If the grid goes down, but the purpose of the storage is to capture energy during peak hours and then to use that in the home for self-consumption to try to offset what you'd buy from the utility. I'm thinking that's the question. If that is the question, then let me know. If not, then we can address it another way. So you can actually do that with the batteries without a system controller. You can run these batteries as grid-tied batteries. And what happens is that PV will actually get directed to the batteries to charge the batteries. And then during peak hours, when you're going to usually buy from the utility, then you can discharge the batteries to feed the loads as opposed to buying it from the utility. So I'm thinking that's the question, or that was the, so if that's.
Yep, that's what Brian said. He said yes.
Okay, perfect.
Yep.
Okay, you can do this with the system controller. It'll function in that way. You have, with the system controller, then you have backup capability too, because it'll disconnect the grid if the utility goes out. But if you install the batteries in a grid-tied only way, then it will just function as grid-tied storage, which will charge and discharge based on loads. And so what our energy storage guy is here. So Bujan, do you have any, if you're still on with us, do you have any additional comment on that? Oh, we may have lost him. Okay, anyway, I think that is the case though. Great, thank you for joining us. Yeah, trying to get back in the swing of things after the beginning of the year. I hope everyone had a great holiday season and transition into 2023. Stay tuned for our February webinar. There's going to be a few more introductions in terms of changes to installer app and things like that. So you want to stay tuned for that. But we did try to really highlight some of the key sticky points in terms of implementing the technology today. And I hope that was helpful. Okay. Okay, thanks everybody. Have a great rest of your January, and we'll catch you in February. for installing and commissioning our backup configured systems.